Hi everyone. Today we are going to see multiple choice question MCQ test on robotics for the unit 4th, robot kinematics and robot programming. First question, which one of the following statement is false regarding rotation matrix? Option A, each row or column of a rotation matrix is a unit vector. Option B, inverse of a rotation matrix is nothing but it's a transpose. Option C, rotation matrices are commutative in nature. Option D, the inner dot product of each row of a rotation matrix with each row with each other row becomes equal to 0. So the answer for the first choice is C. Rotation matrices are commutative in nature. That is false. So it means rotation matrices are generally not found to be commutative in nature. Rotation matrices are generally not found to be commutative in nature. Okay. So this is the false statement. Next question. According to the rule for the composite rotation matrix, a rotation of angle alpha about z vector followed by a rotation of angle beta about y vector axis followed by a rotation of angle gamma about x axis is written as option A, rotation composite equal to rotation z bar z vector comma alpha, rotation of y axis of angle beta, rotation of x axis about the angle gamma. Then B, rotation composite equal to rotation of x vector of angle gamma, rotation of y vector of angle beta, rotation of z axis of angle alpha. Option C, rotation composite equal to rotation of y vector of angle beta, rotation of x vector of gamma angle, and rotation of z vector of alpha angle. Option D, rotation of composite equal to rotation of z vector of alpha angle, rotation of x vector of gamma angle, rotation of y vector of beta angle. So for the choice 2, the correct choice is B, here B, rotation composite equal to rotation of x vector axis at an angle of gamma, rotation of y axis at an angle of beta, rotation of z axis at an angle of alpha. Next question. Which one of the following statements is true? The concept of roll, pitch and yaw angles can be used to represent the position of end effector of a manipulator with respect to its base coordinate system. Option B, represent the orientation of end effector of a manipulator with respect to its base coordinate system. Option C, represent both the position and orientation of end effector of a manipulator with respect to its base coordinate system. Option D, represent neither the position nor orientation of end effector of a manipulator with respect to its base coordinate system. So from the choice For the question third, option B, represent the orientation of end effector of a manipulator with respect to its base coordinate system. This is the right choice for the third question. That is, the concept of roll, pitch and yaw angles can be used to represent the orientation of end effector of a manipulator with respect to its base coordinate system. Next question. According to Denavit-Hartenberg's notations, link and joint parameters represent option A, the relative positions of neighboring links and structure of a link respectively. Option B, the structure of a link and the relative positions of neighboring links respectively. Option C, the structure of a link only. Option D, the relative positions of neighboring links only. So, according to Denavit-Hartenberg notations, link and joint parameters represent the structure of a link and relative positions of neighboring links respectively. It's 4B is the right choice. Fifth question. According to Denavit-Hartenberg notations, the length of height robotic link can have option A, positive value only, option B, negative value only, option C, zero value only, option D, either positive or zero value. So, fifth question, the values are either positive or zero value. Option D is the right choice. Option D is the right choice. Sixth one, according to Denavit-Hartenberg notations, the offset of height robotic link can have option A, positive value only, option B, negative value only, option C, zero value only, option D, either positive or negative or zero value. Hence, the right choice is option D, either positive or negative or zero value. Next question. According to Denavit-Hartenberg's notations, for the revolute and prismatic joints, option A, joint angle theta is considered as variable. Option B, link offset D is considered as variable. Option C, joint angle theta and link offset D are considered as the variables respectively. Option D, link offset D and joint angle theta are considered as the variables respectively. So, for this seventh question, option C, joint angle theta and link offset angle D, link offset D are considered as the variables respectively. Eighth question. Forward kinematics problem in robotics aims to determine the option A, joint angles of a manipulator of known geometry for a given position and orientation information of its end effector. Option B, position and orientation information of the end effector of a manipulator of known geometry for a given set of joint angles. Option C, forces or torques required at different joints of the manipulator of known geometry for the given link offsets or joint angles. Option D, link offsets or joint angles of the different joints of the manipulator of known geometry for the given information of joint forces or torques. So, for this question, option B, position and orientation information of the end effector of a manipulator of known geometry for a given set of angles. This is the right choice. Then, ninth question. Which one of the following statement is false? Option A, Jacobian is nothing but multidimensional form of derivative. Option B, Jacobian matrix relates the Cartesian velocity of a manipulator with its joint velocity. Option C, to determine singularity condition of a manipulator, the determinant of its Jacobian matrix is put equal to 0. Option D, a manipulator gains at least 1 degree of freedom at its singularity condition. So for ninth question, option D, a manipulator gains at least 1 degree of freedom at its singularity condition. This is false, because so at the singularity conditions, at least a manipulator loses at least 1 degree of freedom. A manipulator loses at least 1 degree of freedom, not gains, losses. Okay, a manipulator loses at least 1 degree of freedom at its singularity condition. This is the false statement. Hence, D is the right choice. Then, 10th question. Which one of the following statements is true regarding a serial manipulator? So option A, it's a forward kinematics problem is more difficult to solve compared to the inverse kinematics. Option B, it's a inverse kinematics problem is more difficult to solve compared to the forward kinematics. Option C, computational complexity of its forward kinematics problem is not comparable to that of its inverse kinematics problem. Option D, its inverse kinematics problems need not be solved at all. So 10th question, option B is the right choice. This is the true. Okay, which one of the following statements is true regarding a serial manipulator? Its inverse kinematics problem is more difficult to solve compared to the forward kinematics. Hence, option B is the right choice. 11th question. To determine the coefficients of fifth order polynomial used as a trajectory function, we need to know option A, 4 known conditions, option B, 5 known conditions, option C, 6 known conditions, option D, 3 known conditions. So here for the 11th question, option C, 6 known conditions. So fifth order polynomial used as trajectory function, we need to know 6 known conditions. Hence C is the right choice. Okay, then we will move on to the next 12th question. According to Denavit-Hartenberg notations, angle of twist of ith link is defined as the angle between option A, two consecutive z-axis measured about x-axis, option B, two consecutive x-axis measured about z-axis, option C, two consecutive y-axis measured about x-axis, option D, two consecutive x-axis measured about y-axis. So for this 12th question, option A is the right choice, two consecutive z-axis measured about x-axis. So option A is the right choice. Then 12th question, 13th question. According to Denavit-Hartenberg's notations, joint angle theta is defined as the option A, between two consecutive z-axis measured about x-axis, Option B, between two consecutive x-axis measured about z-axis. Option C, between two consecutive y-axis measured about z-axis. Option D, between two consecutive z-axis measured about y-axis. So the right choice for the 13th question is the joint angle theta is defined as the angle between two consecutive x-axis measured about z-axis. Hence, B is the right choice for the 13th question. Then 14th question, in trajectory planning, option A, Cartesian scheme is preferred to joint space scheme due to less computational complexity. Option B, joint space scheme is preferred to Cartesian scheme due to less computational complexity. Option C, computational complexity of Cartesian scheme and joint space scheme is not comparable. Option D, joint space scheme is never used. So for this 14th question, option B, joint space scheme is preferred to Cartesian scheme due to less computational complexity. Hence, B is the right choice for the 14th question. Then we will move on to the 15th question. In trajectory planning, parabolic blends are used at the two ends of linear trajectory function to, option A, generate linear movement of the end effector of the manipulator. Option B, reduce the manufacturing cost of the robot. Option C, improve the resolution of the manipulator. Option D, avoid infinite acceleration and deceleration at the beginning and end of the linear function respectively. So, in trajectory planning, parabolic blends are used at the two ends of linear trajectory function to avoid infinite acceleration and deceleration at the beginning and end of the linear function respectively. Hence, D is the right choice for the 15th question. And then we will move on to 16th question. The aim of trajectory planning is to, option A, determine a collision-free path for the robot. Option B, ensure the smooth variations of displacement, velocity, and acceleration at each of the robotic joints. Option C, determine the force or torque required at each of the robotic joints. Option D, control the motors connected at various joints of your robot. So for the 16th question, the aim of trajectory planning is to ensure the smooth variations of displacement, velocity, and acceleration at each of the robotic joints. So B is the right choice for the 16th question. Then move on to the 17th question. Which one of the following statements is false regarding the kinematics analysis of MINIMOVER, a 5 degree of freedom serial manipulator? Option A, it's forward kinematics as a unique solution. Option B, it's inverse kinematics as a unique solution. Option C, it's inverse kinematics as multiple solutions. Option D, forward kinematics analysis is to be done at first before carrying out its inverse kinematics. So for the MINIMOVER, a 5 degree of serial manipulator, option B, it's inverse kinematics as a unique solution. This is a false statement. If you refer option C, it's inverse kinematics as multiple solution. So instead of this, it is having unique solution. This is the false statement. Option B is the false statement. Hence, B is the right choice. Then 18th question. Which one of the following statements is true? Option A, rotational x vector axis at theta 1 angle, rotation x vector of axis at theta 2 angle equal to rotation of x vector axis at theta 2 into rotation of x vector at theta 1. Option B, rotation of x vector at theta 1 angle into rotation of x vector at theta 2 equal to minus rotation of x vector at theta 2 into rotation of x vector at theta 1. Option C, rotation x vector at theta 1, rotation x vector axis at theta 2 angle equal to rotation of x vector theta 1 plus theta 2. Option D, rotation of x vector axis at the angle of theta 1 multiply with the rotation of x vector at angle theta 2 equal to rotation of x theta 1 minus theta 2. So hence the answer is C, rotation of x vector theta 1 multiply with rotation of x vector at angle theta 2 equal to rotation of x vector theta 1 plus theta 2. So if you want to check this, you can multiply the LHS side, left hand side, multiply both rotation of x vector at angle theta 1 with rotation of x vector at theta 2. So you may get a right hand side answer, rotation of x vector axis at theta 1 plus theta 2. So the right choice is C. C is the right answer. 19th question. Forward dynamics problem of your robot aims to, option A, determine the joint angles for the known position and orientation of the end effectors with respect to base coordinate system. Option B, determine the position and orientation of end effectors of a robot for the known values of joint angles. Option C, determine the joint angles, velocities, and acceleration for the given values of joint torques. Option D, determine the joint torques for the given values of joint angles, velocities, and accelerations. So 19th question, forward dynamics problem of a robot aims to determine the joint angles, velocities, and acceleration for the given values of joint torques. So C is the right choice. 20th question, which one of the following can have a positive value, a negative value, and also become equal to 0? Option A, area moment of inertia. Option B, mass moment of inertia. Option C, product of inertia. Option D, neither mass moment of inertia nor product of inertia. So the right choice is product of inertia. Product of inertia can have a positive value, a negative value, and also become equal to 0. The right choice is C. Next question. In dynamic analysis of a robot, moment of inertia is used to determine the contribution of Coriolis term in the expression of its joint torque. Option B, determine the contribution of centrifugal term in the expression of its joint torque. Option C, determine the contribution of gravity term in the expression of its joint torque. Option D, determine the effect of mass distributions of the robotic links in the expression of its joint torque. So the right choice for the 21st question is a robot. Moment of inertia is used to determine the effect of mass distribution of the robotic links in the expression of its joint torque. Option D is the right choice. Then 22nd, to learn robotics, which one of the correct sequence to be followed? Option A, dynamics, kinematics, trajectory planning. Option B, dynamics, trajectory planning, kinematics. Option C, kinematics, trajectory planning, dynamics. Option D, trajectory planning, dynamics, kinematics. So from the choice, we have to study the correct sequence is option C, kinematics, trajectory planning, dynamics. So in this flow only, we have to learn robotics, kinematics, trajectory planning, and dynamics. Option C is the right choice. 23rd, for an ideal frictionless rotary robotic joint, its torque tau expression consists of option A, Coriolis and centrifugal terms only. Option B, gravity term only. Option C, inertia terms only. Option D, inertia, gravity, Coriolis and centrifugal terms. So the right choice is option D, inertia, gravity, Coriolis and centrifugal terms. The right choice is D. Then we will move on to the next question. 24th question. The purpose of studying robot dynamics is to option A, determine a collision-free path for its end effector. Option B, ensure a jerk-free moment at the robotic joint. Option C, decide the power rating of the motor attached to the robotic joint after knowing its time history of the trajectory. Option D, study the relative positions of its various links and joints. So among these choices, the purpose of studying robot dynamics is to decide the power rating of the motor attached to the robotic joints after knowing its time history of the trajectory. Hence, option C is the right choice for 24th question. Okay. Then 25th question, which one of the following statements is true? So option A, dynamic analysis of a manipulator with flexible links can be carried out. Option B, dynamic analysis of a manipulator with flexible links cannot be carried out. Option C, a manipulator with flexible links cannot be designed and developed. Option D, a manipulator with flexible links has got no practical applications. So 25th question, option A, dynamic analysis of a manipulator with flexible links can be carried out. This is the true statement. So among all four choices, option A is the right choice for the 25th question. Okay, thank you.